Hey guys, and here is problem 3. As shown in the figure, AC is the diameter of the large half circle, and BC is the diameter of the small half circle. So this is the big one, this is the small one. But there's actually a third one too if you look closer. That's this unshaded portion right here. It kind of looks like Mickey Mouse. Okay. A, B, A, C, and C, B are the three sides of triangle ABC. AC is equal to 4, BC is equal to 3, and AB is equal to 5. Find the total area that is shaded in this figure. So what is an expression we can use to just write out what is the shaded area about? Well, if you think about it, it's really this triangle ABC right here. You can first just, the total area of the entire figure, right? That would be the large half circle plus the small half circle plus triangle ABC. And then what you can do is subtract the area of this unshaded semicircle right here. And then you get the shaded part. So I'm going to do the S. S is just representing size, but it's also what we write for area. So S of shaded, I'll just write shade, is equal to what? So it's equal to the large semicircle, that I'm just gonna abbreviate it, plus the small semicircle, so small, plus triangle ABC, minus the size of the minus the size of the unshaded. But instead of writing triangle ABC, I'm going to rewrite it as AC times BC, AC times BC divided by 2. Why? Because this is the actual formula for finding a triangle, and I just want to be able to write it in terms that we can solve. So now let's just replace, in this next step, let's just replace large, small, and unshaded as the actual formulas you're going to use to solve it. So for the large, that's right here, it has a diameter of 4. So it means that large is going to be, right, this is half of AC. So AC divided by 2. And since we're using AC and BC here, we're just going to be using AC here instead of the 3, 4, and 5, because in the end, after everything is simplified, we can always substitute that in. So as always, a good tip is to first simplify and then substitute. So here we have AC divided by 2 squared and then multiplied by pi. Okay, so that's the large, and then we add the small semicircle, which is BC divided by 2, that squared, times pi. And then of course we have AC times BC divided by 2 minus the unshaded. And the unshaded part would be AB divided by 2, that semicircle, right? Squared times pi. Alright, and I'm just going to write pi over 2 for every single one of these because I accidentally forgot to add that 1/2. So don't make the same mistake as me. Right, because at 1/2 because it's a semicircle. Now let's solve. So after solving, this would become pi over 8, factor that out, and on the inside we have BC squared plus AC squared minus AB squared, right? This, and then we have add AC times BC over 2. So this ultimately, the end becomes just the fraction AC times BC divided by 2. But let's go back and just reference this to the picture. What's AC times BC divided by 2? Well, that's going to be AC times BC divided by 2. That's exactly the the area of this triangle. And this is all equal to the one at the very beginning, the shade. So what we just referenced now is that shaded area, the shaded area right here is equal to triangle ABC. So this is an observation that's not just applies to this problem, but in many other figures as well. So this, maybe you can give it a creative name, maybe the Mickey Mouse shape or the cat shape, if you think it was a cat, maybe koala shape, koala head or koala ears, anything like that. Because these two parts, the axis, say if we think of this as ears in an animal, will always be the same as the triangle formed by their diameters. So that's just something to take a note of. So now we're not done yet because we're actually trying to find the total area shaded. Let's substitute in AC and BC. So AC and BC multiply together, just 12. 12 divided by 2 is 6. So our final answer for this would be 6.